Hey, what's up? My name is Chris, and today I'm going to walk you through how you can build a voice RAG agent using some of our Nemotron models. This voice RAG agent is going to have four main components. Number one, it's going to have the ability to ingest voice through audio files. The model we're going to use can also stream audio, but for the notebook, we're going to stick to a more simple case and just have it ingest audio files. Number two, it's going to have a retrieval pipeline. This is going to include both embedding and re-ranking. Number three, it's going to have a safety model. This is going to help us ensure that our outputs are safe and compliant. And number four, it's going to have a long context reasoning model, which is going to tie everything together and give us some great responses. All right, let's dive right into the notebook and get started. All right, now that we're in the notebook, we have a fairly straightforward flow. We're going to get some voice input. We're going to convert that voice input into text using our NVIDIA Nemotron speech ASR model. We're then going to use our Llama Nemotron embed and re-rank VL 1B v2. That VL means that we can actually have images be part of our corpus, and they're actually going to be in the same index as our text documents. We're then going to pass to a LLM for reasoning. We're actually going to pass to an LLM and a VLM here. This is because we want to be able to reason about those images should we get them. Finally, we're going to pass our output to the safety guard model to make sure that everything is safe, there's no PII, and things of that nature, and that's going to get us our safe response. You can see that we're using a number of models for this tutorial. Now, the first and foremost thing is that we're going to host some of these models on our own GPU using the Transformers library as well as the Nemo framework. We are not going to host all of them, though, as we are going to let those beefier models, which is our Nemotron Nano 12B v2 VL model, as well as our Nemotron 3 Nano 30B A3B model, we're going to let those be hosted on build.nvidia.com since they are quite large. The rest of them, though, can fit on a 24 gigabyte GPU. All right, our first step is to build our index. You can see here again that we have our text documents and our images going into the same embedding model and in the same index. This is going to let us query that index for all queries, and it's going to retrieve text and images, whatever is most closely related to our query. We're then going to, of course, include a re-rank step, which is going to help us ensure we have the best possible documents. Setting up our embeddings is not very difficult. You can see we load the model and we set it up for inference. We're going to do the same thing with our Nemotron re-rank model, and this is going to help us, again, make sure we have only the best documents available. So as you can see, not only can our documents have text or images, they can also have text and images. This is going to help us to build a really rich index for retrieval. Next, we're going to build our FAISS index. Now, you'll notice that we're just using 5 vectors here. You can expand this as much as you want, which is actually quite reasonable to do, given that these models are quite small, despite their relative performance. Next, we're going to go ahead and set up our ASR pipeline. Now, this model is capable of real-time, ultra-low latency ASR. We're going to go ahead and we're going to just leverage it as we would traditional ASR, so that's not real time, in order to keep things simple in the notebook. However, we do have a tutorial that you can check out, which is going to showcase how you can use this model in that real-time environment. Loading the model up is pretty straightforward. Once we've done that, we can give it a test. I have a simple file here in which I say, can you tell me about robotics? That's saved in robotics.flac, and we can go ahead and we can actually do the transcription of this file to get us our text. Last, but certainly not least, we have our Llama 3.1 Nemotron Safety Guard model. What this is going to do is it's going to take some user query as well as an agent response, and it's going to determine if that agent response is either safe or unsafe. As you can see, we can actually determine what content categories we wish to use. What this means is that if we don't want to use all of them, we can simply omit them from our prompt. Finally, we're good to build our LangGraph workflow. This is going to transcribe our audio to text, retrieve some documents based on that text, describe the images, then generate a final response using our reasoning model and doing some final safety checks before we deliver the response to the end user. As you can see, we're just setting up a simple agent state graph. Then we're going to set up some nodes, which are going to help us do each of the functions we just described. Finally, we're going to construct our graph by adding nodes and edges. Finally, we can test our agent out. We can go ahead and include our audio file through this sample audio path. You can see that it was transcribed to "Could you please tell me about robotics?" And then we get a response that's all about robotics, as well as a determination that our output is safe. Thanks so much for watching. All of the resources we mentioned are available in the description. As well, we've produced a blog that you can read through if you want to learn more about some of the particulars of the model, and of course that notebook, which you can use as a guided walkthrough of how to build this really simple voice RAG agent. Thanks so much for your time, and have an excellent day.